Morning, Paul. Morning, Houjie.
Hey, Steve.
How are you?
I just mentioned your name, actually.
Looking forward to Houjie's talk.
Yeah.
Hi, Steve.
How are you? Nice.
Very good.
I'm good. Nice to see you.
Good.
Okay. So, let me see. Oh, 9 o'clock. Okay. Good morning, good afternoon, and good evening. Welcome again to this World Large River and Delta Systems Source to Sink webinar series. Today, we invite Professor Houjie Wang from Ocean University of China. He will talk about the Yellow River-derived sediment. So this Friday, this coming Friday, September 25th, we have another big shot, Professor Swisky. She will talk about Anthropocene, source to sink study contributed to us, whole Earth system. As you can see, she have many overview across the globe, the world large river, small river system. So please mark your calendar this Friday. But remember, the time a little bit different because Colorado time at this moment only 7 a.m. She hope she can start a little bit late. So we will have half-hour delay, 9:30 a.m. Eastern Coast, and London 2:30, Paris 3:30, Beijing is 9:30 p.m. If you cannot really make the live presentation, as we mentioned before, all the presentation is live streamed on the YouTube and archived and recorded over the YouTube channel and also uploaded to the China B station. So you always have a chance to go back to rewatch the presentation. So also next whole week, we have other 2 talks. One is from Edward Tipper from University of Cambridge. He is the first person will talk about the geochemical portion of the source to sink, the water large river system, the reduced silicate weathering. That should be a very interesting talk next Wednesday. And next Friday, we have Edward Anthony, he's the chief editor of Marine Geology from France. He will talk about the river delta and the longshore sediment flux, talk about Amazon, Mekong, Irrawaddy, and the Niger River. So become, our talk series become more and more interesting. So please mark your calendar coming back this Friday and the next week. So our today's speaker is Professor Houjie Wang. Houjie is a professor from Ocean University of China. At the same time, he also is the Dean of the College of Marine Geoscience. And from this Google Scholar webpage, as you can see, Houjie is an expert of the Yellow River-derived sediment study. And earlier his career, he studied the flux, how much sediment from the Yellow River, was the human impact, climate driving all the modern, particularly last 50 years, Anthropocene stage the change. And later on, he focused on more the sediment deliver in the ocean, particularly involved more in-situ observation and numerical modeling work. So I think I will give the floor to Houjie. Houjie, please go ahead to share your screen.
Okay, thank you very much, Paul. Oh, yeah. Okay, good morning, good afternoon, and good evening, my colleagues. So it's my great honor to give a talk on the source to sink system with the Yellow River as an example. And also many thanks to Paul again for his great efforts on organizing these fabulous online talks. So today, my talk focuses on the flux, feed, and transport of the Yellow River-derived sediment in the sea. So this is the summary of recent works in our group with collaborations with Dr. Naishang B Xiao Wu, and Jingping Xu. And the topic of my talk includes the quantification of sediment flux from the Yellow River to the sea with various time scales, and also recent changes induced by the dam regulations. And then the sediment deposition in the delta region as a proximal sediment sink. And finally, the long distance transport of the river-derived sediment to the Yellow Sea through the Bohai Strait. So when we talk about the terrestrial sediment flux to the ocean, we must see John Miniman again and again, who made so great contributions to this important topic. So based on the huge database from the global rivers, he estimated that the global rivers collectively deliver about nearly 20 billion tons of sediment per year to the global oceans. So this estimation is very critical to understanding the global materials cycling. And we can see from this very famous figure, the Asian rivers that mostly originate from the high Tibetan contributes about 20% of the global flux. So the river sediment as products of the weathering process in its source region is transported along the hydrological pathway and eventually delivered to the coastal region and also accumulated in the ocean over a long journey. And we can find there are complicated processes from the source to sink. And mostly the signals have been greatly modulated by the climate, tectonic activities, the changing sea level, and also the intensive human perturbations in the recent Anthropocene. So the sediment sequence preserved in the delta region, in the continental shelf, and also in the deep sea archived the stories of the sediment from source to sink. So among the world's large rivers, the Asian river systems are of great importance as they contribute about 20 to 25% of the global flux to the ocean. We can see that the Yellow River previously delivered more than 1,000 million tons per year of sediment. Then the Yangtze River delivered about 500 million tons. The Pearl River nearly 100 million tons. And then the Red River about 130 million. The Mekong River about 160 million. And for the Irrawaddy, the sediment flux was about 600 millions. And this large system for the ginger spermoptera is more nearly 1,200 million tons per year. It's a very high load comparable to the Yellow River. And also the small mountainous rivers on Taiwan Island also contribute nearly 200 million tons per year. So this is the sediment flux from the large Asian rivers and also the small mountainous rivers have a very important contribution to the ocean for the terrestrial sediment flux. So therefore, the source to sink system in Asia continental margins is featured by has a large spatial range from high mountains to deep oceans, from low to mid latitude. And the source to sink process was highly impacted by the monsoonal climate system. And there are large rivers together with large deltas with very high sediment flux. not only the large river deltas, but also the evident longshore muddy belt. For example, the Yellow River, the Yangtze River, and also the Pearl River. So, and we also can find continuous sedimentary records in the marginal seas. This is very important for us to decipher the information on the past global change and also the information of the environment change. So, and there is a very long history of civilization in this region with highly populated and vulnerable environment. So this is a very important issue to the present society in the Asia. So this is the system of the large river dispersal. And also we can find the River-derived delta are very highly vulnerable to the storms and also hurricanes in this region. And also the Asia rivers present different types of source-to-sink systems, and that favor the comparable studies. For example, the large river systems such as the Yellow River, the Yangtze River, in contrast to those derived from the Taiwan Island that are very small mountainous rivers with very small river basins, but extremely very high sediment yield. And the Yangtze River and the Yellow River delivers a large high sediment flux to the East China Sea, but with very high, with very wide and shallow shelf, while the Ginger's Brahmaputra system is characterized by the submarine canyon capture system. So and also the large rivers such as the Yangtze and Yellow River are highly populated and therefore highly impacted by the human activities over the last several thousand years. However, the sediment yield and transport for the small mountainous rivers on Taiwan Island are primarily driven by the episodic events such as the typhoon and also the earthquakes that induced impulsive sediment delivery. So from this figure, we can find that the episodic typhoon events induced very high sediment resuspension and also high river discharge from the small mountainous rivers, and then changed the dispersal pattern of the sediment in the coastal region. So these major concerts in last October, scientists gathered in Xiamen as hosted by Steve Q in Xiamen University. And also some guys also joined this meeting. We discussed the hotspots of the Asia sediment continuum toward a global perspective. So these major topics include how and how much sediment delivered to the ocean, and the important role played by the climate and human battle for the dominance over different systems. And then to formulate the sediment transport to the strata formation. So we call it from process to products. And finally, the information occurred in the stratigraphic sequence on the shelf and the continental margins, and its implications to the past global change, and also implications to the future change. So this is a summary of the source-to-sink system in the Asian large rivers. And then when we take the Yellow River as an example, because there's no large river like the Yellow has experienced such dramatic change in the sediment flux to the ocean since the middle Holocene. And this river has highly interacted with the human society. So from this figure, we can find that before the Yuan dynasty in Chinese history, the capital city of China's dynasty was mainly located in the middle Yellow River Basin, changing from Xi'an to Luoyang and Kaifeng. But after Song dynasty, the capital city moved to southern China, and then moved to Beijing and Nanjing, and never returned to the middle Yellow River Basin. This is partly because of the high sediment load from the Yellow River and the resultant serious disaster in this area. So based on the shuttle radar topography data, we can identify the historical changes of the channel in the lower reaches. So we find that the Yellow River sediment was widely distributed in the northern China plain due to the channel erosion and migration. And totally, we can see 9 super low delta loops formed along the western coast of the Bohai Sea, and another one was located in the northern Yellow Sea, mainly formed from 1122 to 1855 years. So it's bounded by these super delta loops bounded by the shelly ridges in the western coast of the Bohai Sea. So we will also find that the significant increase of the population in the Loess region, and from the Han Dynasty, the population in the Loess region experienced a slow increase and then exponentially increase during the Ming and Qing Dynasty. So this implied that increasing human perturbations on the Loess region and destroyed the land cover in this area. And from composition of the sediment from the middle Yellow River, so the fraction of the Loess increased from 15% during the Han Dynasty, and then to Ming Dynasty to 55%, and then become a dominant fraction at present. So that means that human activities in this region destroyed the land cover and then increased the sediment yield in the Loess region. And this figured out the change of the land cover in the Loess region from a different period, from the Han Dynasty to Ming Dynasty and to present. And this significant changes in the Loess region altered the morphology of the Loess and increased the sediment yield correspondingly. So from the large tributary in the Loess region, the sediment concentration even increased to be more than 1,000 gram per liter. So this very high sediment load and sediment concentration in the lower Yellow River caused a very serious siltation in the lower channel, and then caused the frequent erosion and migration of the channel. So also caused these very serious disasters. So based on the volume of delta loops and the carbon-14 dating data, so we can estimate the sediment volume and sediment load from the different period. So we can identify the increase of the sediment in the from the Han Dynasty to the Ming Dynasty experienced sharp increase. And over the last 100 years, we can find that sharp decrease of sediment. So this indicated both the increase of sediment, the the increase and the decrease was mainly caused by the human activities. And for the last 100 years, we found the sediment decrease was mainly caused by the soil conservation practice in the Loess region and also the dam regulation that reduced the sediment load to the sea over the last 5 decades. And so far, the land cover in the Loess region has been greatly improved, so that decreased the sediment yield in this region and decreased the sediment load to the lower reaches. And at the conjunction between the middle reach and the lower reach, there is a large dam we call the Yello Dam, completed in 1999. So this dam greatly intercepted the sediment load from the middle reaches. So we can conclude that the soil conservation practice and also the dam interception contributed to about 70% of the sediment reduction. So from 2002, the Yello Dam and also Wanjia Dam and Famixia Dam was jointly used to regulate the water and sediment during the summer season. The regulation was mostly operated at the end of June and only lasted for about 21 days. So during this short period, the flooding water was formed from the dam and then to score the lower reaches and also expel the sediment previously accumulated within the reservoir. So the water sediment regulation indicated that there is a very significant impulsive signals of water and sediment to the sea. This is the big contrast to that in 1950s and 60s. We can find that the natural seasonal rhythm in water and sediment when the river has less fragmented. So before the dam regulation in 1950s, we found a good rating curve between the river flow and the suspended sediment concentration that corresponds to the natural seasonal rhythm. But now the rating curve between the river flow and the suspended sediment concentration was no longer applicable due to the water sediment regulation. And we also found the maximum sediment concentration correspond to the mid-rate river flow, not the highest river flow. That is because the water sediment regulation in the summer season has 2 steps. Only during the second step, the fine-grained sediment within the reservoir could be eroded by the flooding water and then cause a very high sediment concentration. So this is the sediment flux from the Yellow River to the sea over different time scales. So the next part, we can move to the delta. So the modern Yellow River Delta was formed over the last 150 years. It was formed after 1855 as the Yellow River re-entered into the Bohai Sea. So this is also the 10th super delta loop. And in the modern Yellow River Delta, the channel shift and evolution approximately happen every 10 years because of heavy siltation and a very high sediment load. As a result, the delta prograded seaward continuously. The sediment load was more than 1,000 million tons per year. And the progradation rate of the delta was nearly about 22 square kilometers per year. And because of the extremely high sediment concentration in the summer season, so the hyperpycnal plume has been a dominant process for the fine-grained sediment dispersal at the river mouth. When the suspended sediment concentration is high up to 50 kilogram per cubic meters in the flooding season. So this caused the density of the river water, the mixture of river water and sediment is much higher than that of the sea water at the river mouth. So as a result, the river water submerged into the subaqueous delta and transport high concentrated sediment along the subaqueous slope. So from the in-situ observations, we observed in the bottom layer, the low salinity water together with very high sediment concentration, more than 100 kilogram per cubic meters in the bottom layer, and transport delivered the sediment to the deep water along the subaqueous slope. So this hyperpycnal flow favors high delivery of the fine-grained sediment to the deep region and also caused the rapid progradation of the delta. So we used the numerical model, reproduced the hyperpycnal process at the river mouth. So we used the very high sediment concentration, more than 30 kilogram per cubic meters, but with low settling velocity. That means very fine-grained sediment. And this model reproduced the hyperpycnal process. We also found the low salinity and high sediment concentration water in the bottom layer. But when we increased the grain size of the sediment, also increased the settling velocity of the sediment particle. So the hyperpycnal flow at the river mouth disappears because of the rapid deposition of the coarse-grained sediment along the channel before the river mouth part. So this results indicated that the grain size and also the suspended sediment concentration play critical role in the formation of the hyperpycnal flow. So as for the Yellow River lower channel shifted in the recent 33 decades. So for example, when the river channel migrated in 1976 to the Qingchuigou Channel, so the abandoned delta lobe in the north part was experienced serious erosion, with the maximum erosion depth was more than 10 meters. But the presently active delta was rapidly accumulated with the deposition center located at around the present river mouth. So with the maximum accumulation rate is about nearly 20 meters. So if we look at the shoreline change in the right figure shows the abandoned delta lobe. So we can see the shoreline retreated continuously landward because of the cutoff of the supply of sediment and water from the river in this region. But for the present active delta lobe, the shoreline retreated prograded seaward continuously. And in 1996, when the river channel shifted again, the abandoned delta lobe also experienced rapid retreat, landward retreat. So during the recent years after the dam regulation, because of the lower channel erosion, the sediment entered into the sea was much coarser than ever. This caused rapid deposition near the river mouth and caused the increase of the land area in this region. So as for the abandoned delta lobe, there's a very active subaqueous slope failure due to the strong wave actions in the winter. So from the observations in 1980s, the subaqueous the observation of the side scan sonar and also the chirp data indicated frequent landslide, gravity flow by the silty liquefaction. This caused the destroy of the subaqueous slope. This is the recent image by the might beam in the abandoned delta lobe. Also found the morphology of the seabottom morphology of the subaqueous slope in the abandoned Diolko Delta region. And if we compared the chirper profile in 2004 and also the subaqueous profile in 1976, so the red line indicated the depth profile in 1976. We found in the upper slope it was eroded by the strong wave actions with rough sea bottom. And this eroded sediment was mainly transported to the deep water. And also we can find that evident deposition by the turbidity current to the deep water with a smooth sea bottom. So, okay, we then discuss the far-field dispersal of the Yellow River Delta. So the the delta acts as a major sink of the river sediment in summer. However, it would transit to a source for the sediment transport in the Bohai Sea and the Yellow Sea in the winter time. This is an observation in the winter time and summertime. In the summertime, we can find that the sediment discharge by the Yellow River mostly concentrated around the river mouth, both in the surface layer and in the bottom layer. But far from the river mouth, the suspended sediment concentration decreased rapidly. But in the winter time, we found that sediment resuspension along the delta coast becomes a very important source for the sediment dispersal in the Bohai Sea and even to the Yellow Sea. Especially in the bottom layer, we found two centers.
Sometimes it's difficult to cross the Great Wall.
Yeah, so which one is my last page?
Next
This one?
No,
Yeah.
next.
This one?
Yeah, you can go ahead. Yeah, go ahead.
Okay. So there's a big contrast between the summer and the winter in the suspended sediment concentration. In the winter season, we can find a very high sediment concentration along the coast of the delta region. It would be much higher than the summer with 2 orders in magnitude. So now also we calculated the suspended sediment concentration around the delta region and compared with the daily significant wave height in this region. So we found that in the early spring and also in winter season, the sediment concentration was extremely very high. But in the summer season, the low sediment concentration corresponding to the very weak wave actions in this region. So this is the cradle curve of the sediment. So this mainly indicated the monsoonal climate plays important role in the shallow water of the Yellow River Delta and caused very high sediment resuspension in the winter season. And we also identified that the strong winds in winter favor the long-distance transport of the Yellow River sediment and increase the sediment flux from the Yellow Sea through the Bohai Strait along the northern coast of the Shandong Peninsula in the winter. After the strong winds, or when the wind was relaxed or reversed, the sediment concentration decreased and also decreased the sediment flux from the Bohai Sea to the Yellow Sea. And from the observation of the two tripods in the Bohai Strait, we found that when the northerly wind increased, there is a significant increase in the bottom suspended sediment concentration, and when the wind was relaxed or reversed, the sediment concentration decreased significantly to very low. So this is Chen Hao used the numerical model to reproduce the pattern of the sediment transport through the Bohai Strait as driven by the strong winds. So during the period of strong winds from January, the 8th of January to the 10th of January in 2008, there is evident longshore transport of suspended sediment through the Bohai Strait to the Shandong Peninsula and then to the region of the mud patch of the Yellow River-derived sediment. But after the strong winds, when the winter winds decreased, the sediment flux and also the sediment concentration decreased significantly. And also from the fractions of the surface sediment in this region, we can figure the plot of the silt content in the Bohai Sea and Northern Yellow Sea. We found the silt content extended from the Bohai Sea along the coast of the Shandong Peninsula and then extended to the mud patches in this region. This is indicative to the pathway of the sediment transport along the coast of Shandong Peninsula. And we also found that the winter season is a critical time window for the sediment transport to the Yellow Sea. According to the estimation based on the observation and also estimation from the satellite remote sensing data, we found that in the winter season on the winter time is a critical time for the sediment transport through the Bohai Strait. And contribute about 80% of the annual flux through the strait. So, however, the recent studies also indicate the synoptic event of the weather system. For example, the southerly wind gust in winter or the northerly gust in summer impacted the regional circulation pattern through altered the distribution of the sea surface height and then changed the cross-strait delivery and dispersal of the sediment in the Yellow Sea. So contrasting to the seasonally integrated pattern. We also use the numerical model to investigate the combined impacts of wave and tide actions that plays a greater role in dominating the active sediment resuspension and transport in this region. So because the contribution of the wave actions in this region the sediment resuspension and the transport along the coast by the coast current was greatly enhanced. That caused the sediment resuspension very active in the winter time. So as for the distal mud patches in the Yellow Sea, Paul Liu and Professor Yang observed the omega-shaped mud patch with the clinal form based on the sub-bottom profiling system. And the depositor of the mud patch was as thick as 40 meters thick. So it's an omega-shaped clinal form with the depositor located around about 30 meters in water depth. So that implies that rapidly sediment accumulation was not in the nearshore region. So we used the remote sensing data of the sea surface temperature and also the current data to identify the thermal front and also the mixing front in the winter time. So these two frontal systems dominated the sediment dispersal and accumulation in this region. The thermal front was mainly, as indicated by the dashed red line, is located outside of the depositor. But the mixing front is located in the nearshore side of the depositor. And there is a special gap between the mixing front and the thermal front. So between the thermal front and the mixing front, the sediment concentration is relatively very high, but with weak dynamics. So the fine-grained sediment is easily to deposit on the sea bottom. But in the nearshore region, corresponding to the mixing front, the sediment was very hard to deposit on the sea bottom, so with a very low sediment accumulation rate. So this is the figure to interpret the sediment deposition in the nearshore area, as indicated by the red, the blue arrow, corresponding to the mixing front, and the red arrow corresponding to the thermal front. And the thermal front prevents the cross-shore transport of the fine-grained sediment, and also in the outside of the depositor, the sediment concentration is very low, but with low turbulence. In the nearshore region, corresponding to the mixing front, and the mixing front favors the sediment in suspension rather than deposition because of high turbulence. And between the two fronts, the high concentrated sediment are ready for deposition. So if we compared the sediment distribution in the surface sediment, we used the sand fraction and also the accumulation rate in the mud patch. So in the nearshore region, the sand fraction was about 30 to 40%, with accumulation rate about 0.1 and to 0.2 centimeters per year. And in the outside region, corresponding to the thermal front, the sand fraction was about 30 to 50%, with very low accumulation rate, less than 0.2 centimeters per year. But at the deposition center, the sand fraction decreased to 10% to 20%, with relatively high accumulation rate, about 0.4 to 0.6 centimeters a year. So this is confirmed that the two front systems play a critical role in controlling the sediment deposition in the region of the mud pit and favors the deposition center. So, I would like to give a short summary. The Yellow River provides a typical example for the large river source-to-sink system because it has a huge terrestrial sediment load and from the mega delta and also large distal mud deposit in the shelf sea. The Yellow River is highly impacted by climate, geological settings, and human activities, and strongly interacted with human society for thousands of years prior to the Anthropocene. The dispersal of the Yellow River sediment is primarily dominated by monsoonal climate and regional ocean circulation, as well as modulated by short-scale events and combined wave tide actions in the delta region and even in the shelf region. The fine-grained sediment escaping from the delta mainly accumulated in the Yellow Sea and formed the distal mud deposit since the middle Holocene that archived very important information that indicative to the past global change and recent human activities. Okay, thank you very much. I'm sorry because the internet is not very stable. Thank you.
Thank you, Houjie, gave us such a wonderful overview and review of the Yellow River-derived sediment all the way from the source to the river mouth and to the sink and to the sea. So it's a great review and overview. So if you have any question, you can type your question here or prepare to ask. So we have first question from Homber. Homber, please go ahead.
Yeah, thank you, Paul. Thank you, Professor Wang. It's excellent talk. And I'm just curious, like in your opinion, how long, what is the time scale that the Xiaolangdi Dam and the dam system in general of the Yellow River can retain the sediment from the Loess Plateau? How long do you think that dam can, still working based on the high sedimentation rate inside the dam system? And I know there's a new dam is being planned, I think, kind of upstream Semenxia or between Semenxia and Xiaolangdi. So, in your opinion, like how long could this dam system last in the future?
Okay, thank you, Homeboy. It's a very good question, but it's also very hard for me to give an exact answer. Yeah, as for the lifetime of the Xiaolangdi Dam, so we think that over the last 20 years, because of the dam regulation, the sediment accumulated within the Xiaolangdi Reservoir has been exported to the lower reaches and to the delta region. So this elevated the reservoir siltation, and also at the same time, the sediment derived from the Loess region also decreased greatly. Now the annual sediment load at Semenxia Tongguan station is less than 300 million tons per year. That's because of the impact of the soil conservation program in the Loess region. So in this situation, so we think that the lifetime of Xiaolangdi Dam would be as expected, but it's also there's also a large uncertainty because we are not sure whether the climate change in the region in the middle Yellow River could increase the sediment yield in the future. So it's a very hard question to give a prediction. Yeah.
Yeah. Okay. Thank you for your opinion.
So we have two more questions from Bill Mann and Steve Keel. Okay, and if you have any question, if you want to ask a question, if you don't want to type, you can just raise your hand in the participants. Okay, so Bill, go ahead.
I just wondered if the annual flushing of the sediment behind the dams is of a magnitude that's sufficient that you can see any changes at the mouth of the river or in the sea.
Yeah, it's a good question. The sediment behind the dams should be a potentially important source to save the starved delta. But the real question is that how can we export this sediment to the lower Yellow River and to the delta region? So as we know, if we figured out the subaqueous profile of the reservoir, so we can find that there's a large subaqueous delta in the reservoir, and also the deposition of the subaqueous delta mode to the root of the dam. So that means it becomes harder and harder to erode these sediment and export them to the lower reaches. So that mainly depends on how much of the river flow from the middle, even to the from the upper reaches of the Yellow River.
Okay.
Thank you.
Yeah.
Okay, Steve, and after Steve, Tom Bianchi, and then Gil Carnegie. Okay. Yes, Steve.
Okay. Thank you for a great synthesis of the Yellow system. I think a lot about the distal depot centers, and particularly since many of these systems, the sediment discharge is decreasing. What is the long-term fate? And is there a lag time before we start to see sediment starvation in these and degradation of these distal depot centers, or what's the connection between the decreasing discharge and these distal areas? Maybe you can speculate.
Okay, thank you, Steve. Yeah, it's a good question. Yeah, so I think the sediment supply to the distal depocenter in the Yellow Sea, I think should be relatively stable. So although the sediment discharge from the river, Yellow River, decreased presently, but the delta would be potentially a very important source for the sediment transport to the Yellow Sea. So especially in the winter season, the strong wave actions and induced resuspension could supply the I hadn't remember from the literature that about 200 or 250 million tons per year was eroded from the delta region, and the large part of this eroded sediment was transported across through the Bohai Strait and then to the Yellow Sea. And this sediment would contribute to the distal mud center. So I suppose that there should be a relatively stable supply to the distal mud area. Yeah.
Great. Thank you.
So I think Houjie, I think Steve raised a very, very good question. So this is something always in our mind, and we know that distal mud receive a lot of sediment not directly from the river, but could be a resuspension from the proximal depot center. But with time going on, if the less sediment, only now less than 10 million tons from Yellow River, but with time going on, the proximal subaqueous delta become coarse and coarse because not too much fine material available as a source. So eventually, we don't know how long we will see the effection in the distal part, we begin to see that impact, begin to see the slow accumulation rate, or even the grain size become coarse. This is a good question. Somebody should write a proposal to do this.
Yes, I think you're right, Paul. Thank you.
Okay, so Tom.
Yeah, so Houjie, I really enjoyed your talk. It's very, very wonderful summary of the Yellow River work that's been done. This is sort of a follow-up comment that I guess is linked with what Paul and Steve were talking about. One of the interesting things I think that you're pointing out here with this more distal depot center is that we have to remember from the carbon cycling perspective is that as you sort of remobilize mud from the coastal region and deposit it in the deeper areas, you change the dynamics of how it interacts with the atmosphere in terms of whether it's sequestering carbon or producing carbon. And so one of the interesting things I want to comment on is that in this area that you're talking about, the more distal depot center, we've done some work there where actually, that mud deposit is actually pretty stable in terms of the carbon storage. There's not much going on in terms of the reactivity. So this is kind of an interesting thing when you think about how mud has been remobilized because of human activities from the coastal region to a different, deeper region that sort of decouples it from its activity with the atmosphere in terms of CO2. And it sort of, it makes it this storage area for carbon. And so that's kind of an interesting aspect. And I don't know if you've thought about it with respect to the source to sink physical parameters, but I think it's very, very important in terms of global warming and removement of material in the Anthropocene.
Okay, thank you very much for your comment. Yes, it's really a good question, and but also complicated question. So I think we should do some collaborations with the guys for geochemistry to discuss the export of the carbons from the delta region through the Bohai Strait and then to the distal mud deposition, and then also the changes of the geochemical behaviors in the deposition, and also exchange of the carbon in the water, seawater, and also in the atmosphere. Yeah, it's a very good suggestion and idea. So we can we hope to do some work in this area. Thank you, my brother. Hi, Paul. Hi.
Gil. Yeah, sorry, Gil.
Yeah.
Hi, Houjie, it's great to see you. Thank you for a great talk. I look forward to being able to review it in the future. There was so much great information there. I would like to go back to sort of more, present day question a little bit, following on to Hongbo's question. As you know, when I was working with you and Jeff Nittrower making measurements and from 2015 to 2018,
Yeah.
In 2015, there was a water release, but no sediment release. And then in 2016 and 17, I believe there was no water or sediment release. And I think in 2018, there may have been back to a sort of what was more typical. So I don't want to get too much in the weeds, but I'm just wondering, the lack of a release in, a couple of those years, and climate change, because there wasn't enough water coming into the reservoirs. I believe it was a couple of dry years. With climate change, how do you see that, what do I want to say? I guess the policy of the water and sediment regulation, do you think that it's flexible enough to be able to adjust to periods of drought or periods of flooding, with the dams and the release strategy in place? Do you think that will be successful going forward and able to respond on kind of those timescales?
Yeah, okay. Thank you, Gil. So we just submitted a manuscript to AGU Journal for Earth Future. I think it would be accepted in a couple of weeks. So this discussed the sustainability of the water sediment regulation. And also in my paper in 2007, we also discussed about this question. So the water sediment regulation initiated by the dams largely depends on the water supply from the upper and the middle regions. So this is closely associated with the climate change in this region. And in the last several years, there's no water sediment regulation, mainly because of the shortage of the water resource in the middle reaches. Now in the Yellow Basin, the water resources is a critical issue. So this real water must be supplied to those for the domestic use, agricultural use, and also for the ecosystem service in the middle reaches. So this is caused a very strong issue on the water storage. But for example, in this year, there's a lot of plenty of water because of heavy precipitation in the middle reaches. So the high water discharge from the dam to the lower reaches and even to the river mouth with several thousands of cubic meters per second for 2 months. Yeah, it's a very long time. So this mainly depends on the climate signals. Yeah. So maybe in the following years, if the precipitation is very low, there's also no water sediment regulation. Yeah, that's caused the shortage of the fresh water or sediment to the delta region, and caused the delta erosion would be enhanced in the future.
Okay.
Yeah.
Okay, great. Houjie, there's a short question. Can you answer briefly? So from Haijiang Liu Haijiang, he said, Professor Wang, how do you evaluate the contribution from bed load? In generally, you talk about only the suspended sediment are considered. So how much the bed load you think the Yellow River contribute?
Okay, thanks to Haijiang. Yeah, so I could remember a number of the bed load from the Yellow River to the sea. It's only a very small fraction, about 10% or less than 10% of the total sediment flux for the bed load. So maybe the bed load could be increased over the last 10 years because of the water sediment regulation. The clear water was released from the Xiaolangdi Dam. So this clear water has a very strong capacity for delivering the sediment, especially the bed load. But I think it could only account for a very small fraction of the total sediment flux. But I think although the bed load account for a very small fraction, it could be very important for the stable of the delta region. Yeah.
Okay, we have a question from Clark Alexandra. So we have to give credit to Clark. because his earlier work back to his PhD dissertation with Chuck and David Master, work on the Shandong mud patch. And so Clark, please go ahead, ask your question.
Sure. Thanks very much, Paul. I did some very preliminary work. There's been a lot more work done since then, and it's really refined our understanding of those deposits. I was just curious whether Dr. Wang, whether you thought that this mixing front and temperature front controlling where the center of these depocenters are, whether that might be a much more broadly applicable kind of process, because we do, Paul has documented a lot of these longshore cliniform mud deposits, and I was wondering whether they might all be controlled by dual mixing and temperature thermal fronts.
Yeah, okay, thank you for your question, Clark. Yeah, so do you mean the mixing front in the mud depocenter would be applicable to other system of the longshore mud center, right?
I think this is kind of
Right. Yes.
Yeah. So in the mud depocenter in the Yellow Sea, we used the current data from the HICOM to identify the strong mixing through the water column. I identified the mixing front used the Simpson-Hunter index to identify the mixing front location in the nearshore region. So this strong currents in the shallow water usually cause very high turbulence. So this high turbulence can sustain the suspension of the sediment particle. And it's very hard for these particles to deposit on the sea bottom. So corresponding to the very low sediment accumulation rate and also very coarse sediment in grain size. So I'm not sure whether this this rule could be applicable to the other system of with the longshore mud belt. But in the Changjiang system, we also found that the maximum accumulation rate is found in the region of 15 meters isobars, not in the very shallow region. Yeah.
Okay, Clark, is that okay?
Oh yeah.
Yeah.
Great. Thank you very much.
Yeah, Houjie, I have a quick question. When speakers talk about the other large river system, the sediment dredging is a big problem, like the Irrawaddy, like the Mekong. So how about the Yellow River? I guess Yellow River is not a big issue, right? Because there's not too much sand, only silt. Is that right?
Yeah, you're right. So in the Yellow River Delta, there's not so much dredging because of the sediment fraction mainly silt. Yeah. Okay. It's not could be not used for the architecture and no commercial use. Yeah.
Okay. At least that's one good thing.
Yeah.
Okay. Do you have any other question? I know XG have but not really a question. He typed something. So, but if not, I think Houjie, we thank you very, very much. And I would like to remind everybody again, this coming Friday, Jaya Swisky, she will give a great overview, global overview talk about, the last 50 years, the source to sink contributed to the whole Earth system. So please ask your student, your colleague, let them know this talk this week. and also next week, the 2 other great talk by Edward. So, okay, if we know any other question, I think
Paul, I have only one words. Yeah. So I'm sorry because my poor English. It's almost 1 year that I did not speak English.
I mean, your talk is fantastic. I don't think any problem. So
Yeah.
it's our many international colleagues. They are so appreciate your presentation. Okay, it's a great work.
Okay, thank you.
Sure. Okay, I'll see you Friday. I'll see you next week. Okay.
Okay.
Bye-bye.
Thank
So
you very
long.
much. Okay, see you.